All right, let's go through an example of how to solve an OR compound inequality. So we know this is an OR inequality because it actually says the word OR. And the easy thing about these is we just solve them separately and then graph them on the same number line. So the first thing I'm going to do is look at my first inequality, locate my variable, and in order to solve for x, I need to subtract 5. And actually, I am going to put a little line in just to help me mentally separate the left side from the right side. So I'm going to subtract 5 from both sides. Okay, I'm bringing down negative 7x. I'm bringing down my inequality sign. 12 minus 5 is 7. And now I need to divide both sides by negative 7. Okay, and I know that anytime I divide by a negative, that means I need to flip my inequality sign. So my greater than or equal to is going to switch to less than or equal to, and 7 divided by negative 7 is negative 1. Okay, I'm going to bring down the word OR, and then again, just solve this second inequality like I would if I was doing it on its own. So in order to solve for x, I need to add 2 to both sides. I'm going to bring down my 3x, bring down my inequality sign, and for my last step, I divide both sides by 3. Okay, so that means that my full answer here, and I can write it underneath, is x is less than or equal to negative 1, or x is less than 3. So when I go to graph this, I have negative 1 and I have 3. So if it's less than negative 1, that means I'm shading to the left. And I notice it's also less than 3. So since these are going in the same direction, and I know that an OR inequality means that my answers could be to either equation, the best way that I can actually answer this is just by saying that x is less than 3, because that would include x, the numbers that are also less than negative 1. So that would be my final answer.